Bismillahirrahmanirrahim. Dear students, let's solve another problem related to the direct plotting of SFD and BMD. And in this problem we have a cantilever beam and this cantilever beam is subjected to a point moment at the free end which is acting in counterclockwise direction, and its magnitude is 8 kilonewton meter. There is a point load acting in the downward direction with a magnitude of 10 kilonewton, and then we have a UDL let me mark other loads as well. I think it's better to draw UDL up to this point. So UDL, and we have a point moment this point moment is in clockwise direction 5 kilonewton meter, and then we have a point load acting in upward direction and its magnitude is 5 kilonewton. Intensity of this UDL is 10 kilonewton per meter. Let's label these points. This point is point A, B, C, D, E, F, and G. So we have a beam that is subjected to several loads like 1, 2, 3, 4, 5 2-point loads, 2 couples, and 1 UDL. Let me mark these distances, or before that we can mark the reactions. There will be one reaction in the vertical direction, let's call that as RA, and there will be one movement. We can just assume that reactive movement to be in counterclockwise direction, and we can call that as MA. Okay, let me mark the distances now. Okay, this is 3 meter, 2 meter, 5 meter, 2 meter, 1 meter, and 1 meter. Okay, so let's calculate the reactions first. We will apply sigma Fy equal to 0, and we'll take upward forces as positive. What are the forces acting in upward direction? We have Ra acting in upward direction, then we have 5 kilonewton force, another force acting in upward direction. Either we can write it down here or we can move in the sequence and we'll write it down when we reach that force. So Ra in upward direction and 10 kilonewton force acting in downward direction, so minus 10, and then we have this UDL, that is 10 into 5, and then the point moment, it will not come here in this equation, and then we have 5 kilonewton force acting in upward direction, and that is equal to 0. So if we solve this equation, we'll get Ra is equal to 55 kilonewton. So one reaction is calculated. And then for the calculation of other reaction, let's take sigma like sum of moment about point A equal to 0. So we can take sigma MA equal to 0 with the convention clockwise movement as positive. If we apply the condition of equilibrium at point A, what is the first movement at this point? The first movement is this the reactive movement, which is in counterclockwise direction, so it will be minus MA, and then RA is passing through point A, so RA will not produce any movement. At point B, we have this 10 kilonewton force, which is acting in downward direction, and it will produce movement in clockwise direction. So according to our convention, it should be positive, 10 into 3. And then moment due to this UDL, 10 into 5 is the lever arm, and the resultant will be acting at the center in the downward direction, so it will produce movement in clockwise direction. So it should be positive. 10 into 5 is the magnitude, and 7.5 is the lever arm. 3 plus 2 plus 5 by 2. And next we have 5 kilonewton meter moment, which is acting in clockwise direction, so it will be positive 5. Now this time I plan to use the same diagram for the plotting of shear force and bending moment diagrams. So I will not move in the same line, rather I'll jump to the next line, the remaining part of the equation. Plus 5, and then we have this 5 kilonewton force which is acting in upward direction, and its lever arm with respect to point A is 13, and it is producing movement in counterclockwise direction. So minus 13 into 5 or 5 into 13 and then we have the last movement, which is minus 8, because it's counterclockwise, minus 8, and that is equal to 0. So if we solve this equation, we'll get the value of MA, and MA comes out to be 337 kilonewton meter. This is the value of second reaction at support A. So this completes our reaction calculation. Now next part is to draw shear force diagram and bending moment diagram. This time I will be using the same diagram. If you guys like, you can also do the same. Especially in exam, when you have limited time, it's a good idea to use the same diagram. On the same diagram, we will just write down the magnitude of these reactions. RA is 55 kilonewton and MA, you can write it down on this side, 337 kilonewton meter. Now we will draw the guidelines for the plotting of SFD and BMD. Okay, so first let's plot shear force diagram. SFD, and the units are kilonewton, and this is our 0, line. At support A, RA is acting in the upward direction with a magnitude of 55 kilonewton. So from 0, we will move in the upward direction, will go up to 55 kilonewton. And then from A to B, there is no point load acting, so we will move straight 0 line. And at point B, there is a point load acting in downward direction with a magnitude of 10. So 55 minus 10 will bring us to 45. And then at point B, we are done with point B. While moving from B to C, there is no point load acting. There is no load acting, so this will be a straight line, 0 degree line. And then at point B, at point C, there is a UDL starting at point C. So the shear force diagram for this portion will be an inclined line. Magnitude is 45 at this end, and 45 minus area of this UDL, which is 10 into 5. So 45 minus 10 into 5 will bring us to minus 5, right? So the value of shear force at this end will be minus 5. Now let me draw this. It's a first degree line, and this value is 5. And then at point D, there is no other load acting. So from D to E, there is no load acting, so it will be a 0 degree line. And at point E, there is a movement, but we know that movement will not reflect in the shear force diagram. And from E to F, there is no other load acting, so it will again go straight. And then at point F, we have another point load acting in the upward direction with a magnitude of 5. That will bring it to 0. And from F to G, there is no load acting, so it will remain 0. And at point G, you can see that the shear force value is equal to 0. That closes our shear force diagram. So this part of shear force diagram is positive, and this part of shear force diagram is negative. And again, in this shear force diagram, we have a point of 0 shear, and we know that we need to calculate the exact location of this point of 0 shear in order to plot the correct bending moment diagram. So we will draw a guideline here for bending moment diagram, and we need to locate how much is this. And again, we can make use of similar triangles concept. We can call this as x, and this will be 5 minus x, because we know that from point C to D, the distance is 5. So if we are assuming this to be x, this distance will be 5 minus x. Now we will use the concept of similar triangles. This dimension is 45. 45 over x, if I write it down here, 45 over x should be equal to 5 over 5 minus x. And if we solve this equation, we get x is equal to 4.5 meter. So x is equal to 4.5 meters.